Uh, Good evening, although I've heard that some people are coming in from New Zealand, so that would mean good morning applies, and it might even be good afternoon somewhere. So we're a worldwide global gathering here tonight, but there's quite a few local Asheville Jubilants, so good to see you all. My name is Stephen Martin. I'm a Jubilant in Asheville, and I haven't been able to make the Sunday meetings in a while, so you may not have seen me, but glad to be joining you. I've got a little bit of a cold that I'm recovering from, so forgive my voice. I'll be keeping that lubricated with some water, but glad to be here, and thank you for contributing to Jubilee and for sharing in this.
Please, either you do it or I do it.
There we go. Let's
Okay.
got it there. And sharing this time together. I'm a professional astronomer, have been for many years, and of course, I'm in love with every image that the James Webb sends down, as many of you are, I'm sure. 30 years ago, I worked for the Hubble Space Telescope in a similar situation. Right, I was there at the very beginning, and every week there would be just some incredible image that would come through that would cause a minor revolution in astronomy. And this is a similar situation. James Webb is sending back such incredible images, such incredible data. It's probably going to rewrite some of the textbooks, what some of the things they're finding, and we'll talk about some of that. And we'll talk about how what we're finding out about the cosmos tells about some of the dynamics that we find here on Earth. I was struck, I'll start my presentation in just a minute. I was struck with the initial launch of the James Webb images, how many of the images they were showing represented human themes, right? There was star birth, right? The birth of something new happening. There was the lives of stars, how stars undergo change over time. There was star death. There was transformation. There was relationality. They were very human themes representing these cosmic images. And so one of the things that I think James Webb is doing is providing a portal for kind of the cosmic dynamics to be reflected in our human lives, or human lives in the cosmic dynamics. Now I'll talk about that a little bit more. And I want to reflect on what the James Webb is bringing us through the lens of the vias, right? The 4 vias that we talk about at Jubilee. We're currently in the via negativa. And so we'll go through the vias and see how those vias are being expressed in the cosmos through the eyes of James Webb and some of the other telescopes there. And then we'll also unpause and we'll have time for reflection and comments and questions and other chances to gather together. So I'm going to share my screen here. And first of all, I want to thank Michelle for helping organize this, and all the Jubilee Committee, and also the Creation Spiritualities communities that spread the word around the world about this event. We've raised a good amount of money for Jubilee, and thank you all for contributing and being a part of this. So I want to start, let's see if you can see this. How is that? Can you see this, Michelle? Everyone seeing this? Good, okay.
Yes.
Yeah, good. So this is an image from the James Webb, and it's a quote from Thomas Berry, and I'll just read it for those of you who are either listening or receiving the recording at a later time, because I think he speaks about something that the James Webb is really reaching for. We will recover our sense of wonder and our sense of the sacred only if we appreciate the universe beyond ourselves as a revelatory experience of that numinous presence whence all things come into being. Indeed, the universe is the primary sacred reality. We become sacred by our participation in this more sublime dimension of the world about us. And for those who don't know, Thomas Berry was a scholar of world religions. He was a Passionist priest. He was a cultural historian. And he really said decades ago that we need a new story of the universe. We need a story that includes us as part of a creative participatory reality. And I'm struck by this word that the universe is a revelatory experience. I mean, that's religious language, but it's also what the James Webb is doing. It's revealing new dimensions and new vistas of the universe to us that we find resonating in our experience. And in fact, I'll advance here to the next slide here. Here's some artwork that I found on the James Webb website. If you take a look at this, this is very much a connection between the human realm and the cosmic realm and the mythological realm. I mean, there's mythological dragons there. There's, the Big Dipper and Ursa Major and all the star myths and the cosmic dimension of things. And it's all being reflected through James Webb's mirrors to different avenues of human culture. There's education, there's art, there's science, there's engineering, there's all kinds of different expressions. So it's really interesting how metaphorically the telescope is a reflection of human culture and connecting it with the dynamics of the cosmos. And I also see that the James Webb is an extension of the human desire to connect with the universe, right? We have this longing to connect with something larger than ourselves, right? This is very much a mammalian trait. As mammals, we have a strong desire for bonding, right? First for being with our mothers and our family, our tribe, and then our larger home. And they stated right out that the James Webb was built so that humans could connect with the origins of everything, which is the origins of the universe. And so I can see it's really representing this human desire to connect with something larger, to connect our lives with our birthplace, which is the cosmos, right? This evolutionary story, which includes us in a 13.8 billion year journey. So it's no wonder that the literal mirror is a mirror for humans reflecting the cosmos. This is a great picture of the engineers, taking a selfie with the mirror. The mirror is also coated in gold. I mean, there's scientific reasons for that, but gold is such a mythological metal in any case. So I'm going to reflect upon this as the James Webb as an instrument of revelation. It's an instrument of myth and metaphor, of weaving human experience with the experience of the cosmos. And the way that I'm going to look at this is through the vias, the different vias that we talked about in Jubilee. And I'll review those in just a little bit. But it's also, an incredible work of engineering, art and beauty. And I want to see if I can do this. I want to show you a video of the James Webb unfolding, right? Because it's just beautiful. It's a work of art just to watch it. I'm going to share here and take a look here. I'll share sound. There's some sound here. If you just watch it here, first of all, it was all folded up so it could fit into the nose cone of a rocket, so it could be shot 1 million miles into space. And I'll say more about why that is. So they had to design this telescope very much like a piece of origami. In fact, the engineers studied origami, the Japanese art of paper folding, so they could fit everything into the rocket and so it could unfold perfectly like a flower once it was in its position. So take a look at this. Isn't that amazing? I mean, and the fact that it actually worked. I mean, it worked perfectly the first time. Oops, sorry about that. And the engineers, of course, develop new patents and developing all these materials, and just astounding. I mean, but it's unfolding like a flower, like a giant golden eye, a million miles out in space. So imagine humanity creating this golden eye, sending it a million miles out in space so it could touch the cosmos more deeply. What an incredible instrument that the James Webb is. Just to reflect a little bit about the properties of the James Webb. And let me make it full screen again. Okay. There we go. So it's about the size of a large truck. It's about twice the size of Hubble. The Hubble Space Telescope is the size of, an American large school bus. James Webb is about twice that size. It's actually about half the weight. So the engineering materials that they use is very advanced. The sun shield here, these layers of protective sunscreen are here to protect the telescope and its instruments from the light from the sun and the earth, because that would overheat the telescope and blind it, because it performs at infrared wavelengths, which is sensitive to heat. This is about the size of an American tennis court. The mirror itself is over 21 feet across. Hubble's is 8 feet across. So it's quite a bit more collecting area than Hubble. And everything is cooled down to make it as cold as possible, because the telescope is sensitive to infrared light, which we humans perceive as heat. So if you put your hand up against something, there are actually infrared sensors in your hand that are receiving the light from that object and reading it as heat, but that's infrared. Objects which are not quite as warm as the sun emit a lot of infrared light. So humans emit infrared, the Earth, planets, smaller stars, they're just forming, emit infrared. And there's other properties of infrared that I'll talk about in just a little bit. And that's one reason why the mirror is gold, is because gold is a very excellent reflector of infrared light. And so this entire telescope is optimized to study the universe at infrared wavelengths, which is a wavelength range that Hubble can do a little bit with, but not quite as well as the Webb. So it's optimized for that for a number of reasons. Now, I'll say more about that. It's also at a point called L2, which is 1 million miles from Earth, where it's stationary with respect to the Earth and Sun. So as the Earth goes around the Sun, the orbit includes the James Webb, and the sunshade is pointing, in the direction of the Earth and the Sun to keep all this heat on this side of it, and the instrument is over here. It can still observe the entire sky, but it's blocking out the Earth, Moon, and Sun as heat sources. So that's why they had to put it all the way out there. And once it's out at this point, L2, it's gravitationally balanced. So you don't need to have any fuel to maintain the orbit. And it doesn't orbit the Earth the same way that the Hubble does at a distance of 350 miles. This one is 1 million miles out. So there won't be any repair missions sent out to it. It's way too far for astronauts to go, for rockets to go. Once it's out there, it's out there. But it's working flawlessly, better than expected. Just a tremendous instrument so far. One of the insights, and perhaps the greatest insight, some people have said, of the past 300 years of science, is that we live in a developing cosmos that had an origin. And this is from an astronomy textbook from a course I taught at the college level. But basically, we are part of a 13.8 billion year cosmic lineage that began with some event that scientists call the Big Bang, and Matthew Fox and Brian Swimme call the flaring forth. Some initial event that happened 13.8 billion years ago. And this universe, which is really a creative process, has been developing steadily over 13.8 billion years, leading first to particles, to galaxies of the first stars, which the James Webb will study in detail that the Hubble hasn't been able to see yet, to the formation of rocky planets, to chemistry, to biochemistry, to culture, to finally this conversation, right? This conversation that we're having, this reflecting on wonder, has been 13.8 billion years in the making. And the universe is still evolving, it's still changing. And so in this view that Thomas Berry, Brian Swimme, other people have been articulating, the universe isn't a thing, it's not a collection of objects, but it's a creative process that's 13.8 billion years in the making and is still ongoing, moment by moment by moment. And so in the creation spirituality tradition, we find ourselves in a dynamic transformed reality that we call the universe, but we express it in terms of the viyas, right? These are different pathways that reality expresses itself in our lives and the dynamics around us. And I put this in the order that we find ourselves in right now. We're in the midst of the Via Negativa, which happens in the fall, where we celebrate the mysteries that surround us, which include black holes, cataclysm, destruction, dissolution, space and mystery. This is right from the Jubilee website. Matthew Fox's Creation Spirituality website has a slightly different version, but essentially the same. And then we go into the Via Creativa, which I'll talk about, which is winter, which is the apparent dormancy of winter, but the underlying imaginative and fertile creativity that underlies everything. So this is the fertility of the void, the potentiality of everything, the creativity that's patterning beneath everything, that's guiding the development of things. And that leads to the Via Transformativa, which is spring, which is the emergence, which is the renewal, which is the resurrection. This is birth, this is initiation, this is generativity, right? The bursting forth of spring with all the flowers and wonder of that time of year, leading to the Via Positiva, which is the summer, which is the sustaining, the beauty, wonder, and awe, the positivity, the expression, the magnificence, expansion. So these are the different vias. All of these are different avenues by what the cosmos can be known. And because we're in a dynamic reality, all of these are portals into that dynamic reality. And so the James Webb is really, it's a via, right? It's a portal through which the vias can reflect upon the cosmos and human experience, where human life comes into contact with the very light and dynamics of the cosmos, right? Through the vias of creation. So I want to start with the Via Negativa, right? And Thomas Berry famously says, universe is not a collection of objects. It's not a bunch of stuff that's like a large room that things are arranged in, but it's an ongoing communion of subjects, right? It's a process by which things are coming into greater interrelationship with itself, right? Complexifying, creatively expressing, optimizing itself with greater differentiation, greater intimacy with itself, and greater interrelatedness. So, Thomas is really saying, we don't live in the universe, we are the universe reflecting upon itself. Carl Sagan, the astronomer, also said the same thing, but we're part of a creative process that's 13.8 billion years in the making. And that's a wonder in itself. And that's part of what the James Webb is looking for, is how did this process come about? What's the nature of it? How is this actually happening? But whatever is happening, we're part of it, as are the redwood trees, the forest, the sun, the earth, and everything around us. So because the Via Negativa is about that which is not present, that's not lit up, I want to focus on the types of light that the James Webb focuses on, literally, and that's infrared light. So light expresses itself in an entire spectrum of different wavelengths and frequencies. We see this narrow band called the visible, which is about 1% of the total wave bands that are out there. You listen to radio light on your radio in your car. There's gamma and X-rays, which are produced by high intensity objects. There's ultraviolet, which gives you a sunburn when you go to the beach. The Hubble is optimized for a little bit of ultraviolet, mostly visible, a little bit of infrared. James Webb is optimized almost entirely for infrared. So all the objects that we see with the infrared, all the light that it's collecting is essentially the invisible. So it's making the invisible visible through the beauty of infrared light and those gold reflective mirrors. The other property that infrared light has, it has its ability to penetrate dust and gas. And so one of the features of the James Webb is that it's designed to study the formation of stars. Stars form in huge clouds of gas and dust called nebulae. And these clouds of gas and dust are very thick, they're very dusty. You can't see them very well. This is an image on the left here of what's called the Pillars of Creation. This is part of the Eagle Nebula, which is a summertime object we can see with binoculars and telescopes from our latitude. And inside each of these pillars are roughly about 1 light year in height. Right? And by that, I mean it takes an entire year for light traveling at light speed to go from the bottom of this image all the way up to the top. That's how immense these pillars are. And each of these pillars is forming something like 10,000 stars at this time. Well, that's incredible, right? Wouldn't we love to know more about that? But we can't see inside the pillars because there's so much dust. Well, look at the James Webb. With infrared light, we can see through the pillars as if they're not there. It penetrates the dust to see the tiny stars that are forming inside the nebula. This is the same technology that firefighters use to find people trapped in hidden buildings that are filled with smoke. The infrared light penetrates the smoke, allows you to see the occupants inside, and people can be rescued that way. So the James Webb is making the invisible visible, right? It's using the via negativa to reveal something which is previously hidden, right? Locked behind here. I'll come back to the pillars of creation in a little bit. This is one of the first images that the James Webb released. This is a deep field image. In other words, it's an image looking very, very far away in space, which means very far back in time. And every dot in this image, dots that don't have these stars in, which are foreground stars, every dot in this image is essentially a galaxy, right? A galaxy is a collection of hundreds of thousands or millions or hundreds of billions of stars. And so every dot in this image is a galaxy at some distance from us. So all of these galaxies are at different distances, which means we're seeing them at different times. This cluster of white galaxies in the center is a massive cluster of galaxies that's roughly 4.6 billion light years away. This is the closest object in this image, aside from these foreground stars. And the reason why they took the image here is because this foreground cluster has so much mass, it's actually warping the light that's traveling around this cluster, causing these arcs of galaxies to be spread out and acting like a magnifying glass that allows us to see a little bit further than we would otherwise without the cluster. So it's using the gravity of this cluster as a magnifying glass to see a little bit further than we would otherwise. And we're seeing so far back, I think the furthest galaxy in this image is something like 13.1 billion light years away, which means we're seeing it not as it now, but as it was 13.1 billion years ago, back when the universe was very young, when these galaxies were very young. So it's just an astounding image. And so the invisible force of gravity, right, the negativa of this image is acting as a magnifying glass. The other component in this image that we're not seeing, that's especially prominent, is dark matter. One of my professional research specialties is in the study of dark matter. And dark matter is something in the universe that has gravity, has gravitational influence, but it doesn't emit any light. So it can warp space, it can warp time, it can warp light, it can focus light. You can see its effects, but you can't see it directly. And we now know from studies of lots of different clusters that most of the mass of these clusters, in fact, most of the mass in this image, is made out of dark matter. Something which is invisible to our eyes, that light passes directly through, but that shapes the dynamics of everything around us. So our world, our solar system, our galaxy is being shaped by dark matter, right? The via negativa of the cosmos. We have no idea what it is, but we know there's so much of it around, it's actually shaping the world around us. Just remarkable. And we're using it as a magnifying glass in this image. A few more slides and I'll pause for reflection and questions. Now, of course, the most famous example of the via negativa in astronomy are black holes. And that's another object that the James Webb is going to be studying as well. This is an artist's conception of a black hole. We don't have images of black holes this close up, but the black hole is at the center of this whirlpool here. That's this dark region from which no light escapes. This is called an accretion disk, where this black hole is spiraling off matter from a companion star. It forms a disk, almost like a whirlpool where it's going down the drain. And the material's going down the drain so fast, the black hole can't swallow it all. And so it shoots up these jets of material from the disk that's another giveaway that the black hole is present. So these are called accretion jets, jets of material that the black hole can't swallow, and so it gets compressed and shot out in either direction. But in the center of this black hole is essentially nothing. It's a hole in space. It's an area where gravity is so dense, it's actually warped space around itself and disappeared from our universe. So it has mass, but it doesn't emit light. It influences things around us, but is unchanging in itself. And James Webb is going to study the areas around these accretion disks of black holes. So clearly, via negativa. So it's showing us that there are many aspects of the invisible world that are influencing our lives right now. Right? You might take a moment and reflect upon some of the invisible influences you might not always appreciate, right? They're friends, organizations, people, places, beings that are influencing your life right now. We want to acknowledge them and also maybe share some appreciation with them. Right? Even though the trees are largely invisible to us, maybe if we're indoors right now, they are providing the oxygen from which we're breathing. Right? The sun, even though it has set where I am right now, it's providing the light and warmth through which the earth maintains a stable temperature and has energy. So we're acknowledging the presence of the invisible in terms of making our visible lives sustainable. Now, in the Via Negativa, there's loss, there's destruction, there's the invisible, there's also death. And the James Webb is revealing beauty and death. This is an image of the Southern Ring Nebula, and it's what's called a planetary nebula. It's a nebula that happens when a star like the sun reaches the end of its life. The star collapses, it throws off its outer layers and a final blaze of glory. These layers drift off into the cosmos, blend with other clouds, and become the raw materials for making a new generation of stars. And what's left over at the end is a white dwarf, which is basically the spent core of the star that shines brightly initially, but isn't generating energy and eventually cools down. So even in death, the James Webb is showing us that there's magnificence, there's pattern beauty in this process of loss, destruction, of something going away. Right? Life is a transformational process that includes birth and death as another part of that process. James Webb is also designed to study very tiny objects, right? Objects such as low mass stars, stars which are smaller than the sun, and also brown dwarfs. Brown dwarfs are stars which don't have enough energy to ignite in nuclear fusion, but are too big to be planets. So they're kind of in between. Are they planets or are they stars? Well, they're kind of halfway made stars, right? They're too big for planets, about twice the size of Jupiter or larger, but they're too small to become formal stars, and so they're called brown dwarfs. So these are the little unacknowledged parts of our galaxy, right? So imagine the unacknowledged parts of our society, right? The little people, the people that we wouldn't normally notice, the invisible people on the streets. Well, like them, these brown dwarfs probably make up most of the mass of the galaxy. Right? Most of the galaxy is made up of the little ones, the little people, the brown dwarfs that we don't see. And so James Webb is going to study these brown dwarfs because they can be seen at infrared light better than in other wavelengths. So through the Via Negativa, we want to acknowledge the small but the mighty, right? Those who are often overlooked, but who have the capacity to influence the whole. And this next image, this is an image from the Hubble of a spiral galaxy called M51. This is the Whirlpool Galaxy. And we think this is a galaxy that looks very much like our own Milky Way as seen from above. And it's a spectacular galaxy. All of these reddish areas are places where new stars are being born. These thick brown streaks here are clouds of gas and dust that are ready to form stars, and stars are forming around these clouds of gas and dust. And the yellow in this image is the blending of hundreds of billions of stars, all blended together. But what you don't see are the brown dwarfs and the small stars in this image. They make up most of the mass. Turns out for galaxies like this, most of the light from the stars in this image comes from massive stars, from the big stars, from the superstars. I mean, how much of our cultural bandwidth is taken up with celebrities, right? They have most of the limelight, but how much of the real work is done by the little people? It's the same with the galaxy. We've got the big stars making up most of the light of the galaxy, but it's the little stars that shape the entire dynamics, that make up the bulk of the gravity of the influence. And so it's remembering that it's the little ones that the whole follows, because they've got the pull all together. So I'm just going to pause here, see if people have any reflections or comments they want to offer. You can unmute yourselves and share something. Or is there anything people are discovering about the Via Negativa? Yes, I can't see anything besides your number, but 981-006. You raised your hand.
That's me. Okay, you got me. First of all, thank you. This is a very healing, expansive experience for me. Thank you.
Oh, I'm glad.
I just sent a thing on Einstein to everybody. I hope they get it. Einstein's view on this is one of, we got to become a child, which is what Yeshua or Jesus said, become again like little children. Lots of things are crossing my mind. Let me begin with, let me go across spiritual belief systems for a moment from my own limited view or understanding.
Just briefly, we have other questions too, but yeah.
The Buddhists have the concept of anicca, impermanence, constant change. They embrace the quantum flux notion. I think they are excited about that everything is always changing. Certainly what we're seeing with the web is that everything is, some things are dying, some things are beginning, some things are being absorbed by black holes, etc. Well, everything is cycling in Buddhism. And then I jump over to Hinduism, which there's an Upanishad. This is the wisdom that somehow we get from 2500 to 3000 BC in the Hindu, the first written spiritual practice. They had a expression that I particularly like is, he who knows it doesn't know it, but he who doesn't think he knows it, knows it. And I think it's that kind of humbleness that brings us into a consciousness of mysticism. The mystics never tried to put God or whatever they called into a box. It was always ineffable for them. William James, the father of American psychology, said one of the characteristics of the mystics, I'm a psychologist, so I like William James, but he said that the characteristic of mystics is that it's ineffable, the characteristic of any mystical experience. And so I want to jump down to Shiva, for example, in Hinduism. It's looked at as the destroyer of the old to make way for the new. I'm paraphrasing that from my own interpretation, to make way for the new creation. So that is deep within the heart of Hinduism as another spiritual belief. And then I jumped to Thomas Merton, one of my heroes. He said, the radical truth of reality is that we are all one. And in that sense, my own article on my website, I talk about we are made of the stuff of stars, and we eat photons, essentially, because the plants grow through the photons. And whenever we do, what happened, I think, is there was a split between science and spirituality.
Let's just pause here and take time for other comments. But I really hear what you're saying about the conflicts between science and mysticism. It's such a creative interface right now. But yeah, thank you for that.
It's a good intervention.
Yeah, we'll have time for more reflections later, but I want to take Carol's question too. As well. Hi, Carol, great to see you.
Thank you. Wonderful to be here and to get these insights, this different way, helping me see these images. These images are quite common, but until you know how to see it or what to see, what you're looking at, they're just images, so it's very exciting. I want to go to, my question is about the black holes, and I'm very interested in symbols and symbolism and symbols for these times that help us tell this story. So around the black hole, in what you call the accretion disk, would you say that gravity that is drawing things down, that there was a spiral in that? Could you see the spiral? Am I
Sure.
reaching?
Yeah, I would say it could be visualized as a spiral as the material spirals into the center. Yeah. So
That's all?
that's certainly a sacred image, right? That spiral, right? So it's taking in information.
Mhm.
Yeah, I'm going to talk about that again, especially with black holes, because they have such a reputation as destroyers, but they're also creators, right? They are the linchpins that hold galaxies together. And the James Webb is going to study that as well. How do black holes contribute to forming galaxies, but also maintaining them? So they're both creators and destroyers at the same time. So
Oh, there's the paradox of everything. Thank you.
yes, yeah. Thank you, Carol.
I
Yeah,
have a question.
sure. Yeah, I'll take one more, and then I want to continue on. Go ahead.
Uh, the idea of dark matter is very mysterious and provocative. It lends itself to mystical ideas. And
Sure.
I'm wondering if you could say a little bit more about the latest understanding of that.
Yeah. We've been studying dark matter for something like 70 years, and we still have no good theory about what it actually is. There's a lot of research that shows that there's something out there. And is it matter? That's probably not the right word. We probably don't have the right concept for it. But what is it that influences things with gravity, but doesn't emit light? So it's a whole new category that we don't really have words for. People have thought about it as maybe some new kind of particle that we haven't discovered yet. And so they've been looking for it deep underground in the depths of the earth. They've been putting these particle detectors down there, looking for them, for dark matter particles. They haven't seen any. Astronomers have looked for it in the cosmos by mapping out these clusters and how these clusters are shaped by invisible forces, which are basically dark matter. Dark matter seems to be the scaffolding upon which the cosmos forms. So imagine an invisible spider web, and imagine stars and galaxies forming as droplets along that spider web, right? The spider web's invisible, but you see this patterning happening in the cosmos around certain places where there's concentrations of gravity. So we see the results, we see the influence of dark matter, but we don't see the matter itself, which is very, very puzzling, very, very enigmatic, very mysterious. Guaranteed Nobel Prize to the first person who discovers what dark matter is. The other mystery that's present now is dark energy, right? Something called dark energy, which is causing the universe, we think, to expand faster and faster over time, right? Normally gravity is attractive and it will try to bring things together. So it should be slowing down the expansion of the cosmos if it's expanding outwards. But there's something there that's acting like a anti-gravity repulsive force, causing it to go faster and faster. So we've measured it. We've measured its influence, but we have no idea what it is. Is it some new form of energy? Is it something else? No idea. Another Nobel Prize, whoever finds out what dark energy is. But together, dark matter and dark energy make up, we think, 96% of the universe. So in other words, the light that we see, the light that we can see with all our telescopes, with all of our detectors, represents 4%. So is there a lot of mystery out there? Absolutely. Right. In fact, Duane Elgin, right? If you know the writer Duane Elgin, he says that the solution to our problems is probably not material, right? So materialism is probably only 4% of the solution. If the universe is only 4% material, that maybe we need a great psychological, spiritual transformation to create a new culture. We don't need more stuff. We don't need some new technology. If most of the universe is something other than the material world, then we need some different kind of revolution. All kinds of things to reflect upon here, but we're in the midst of a via negativa universe where 96% of it is invisible, shaping the 4% that we're a part of. All right. Let me continue on with the next via, and we'll have time to reflect a little bit more later. There we go. In the via creativa, right, we find that there is imagination and creativity that underlie all of the creativity at every moment. So words that resonate in the via creativa are potentiality, fertility, void, creativity. And so we find that this timeline of the universe isn't so much a linear timeline, but it's more like a kind of unfoldment. And so this is a logarithmic diagram of the history of the universe, with the very beginning here, unfolding out like a spiral shape to galaxies, to stars, to the formation of the Earth, planets, the moon, the oceans, life forms, all the way out in a logarithmic spiral here, back to this leading edge, which of course is burning, ever into the future here. So I love how people are trying to visualize this in different ways, because certainly the universe's evolution has not been a linear process, like A to B to C. No, it's a creative process that involves creative emergence out of some kind of potentiality in every moment, right? At the very beginning here, right, these gazelles, these giraffes were pure potential at the very beginning. It wasn't until the very conditions were present that the Earth could give birth to them that they were evoked forth out of this potentiality. So this is the via creativa, that underlying creative potential that's present in the universe at all times, in all places, just waiting for the right conditions to burst forth. And so it's a chance for us to study our own creativity and to consider what are the conditions through which my creative potential bursts forth most strongly in my life, and how can I build my life around that creative potentiality? What activates my creative potential? When do I find myself being inspired in new creative ways? And how do I create those conditions? Because in the via creativa, it's not us that's the source of creativity, it's the cosmos. It's this cosmic potentiality that's bursting through us, if we can only create the conditions for the universe to do its work through its creative potential. We can look at this image of the James Webb of phantom galaxy. So a galaxy is not so much a collection of stars, gas, and dust as it is a swirling creative process. I mean, how could you argue with that with an image like this? Right. So here we have this galaxy evoking new possibilities into being through the dynamics and interaction with itself. Right. Tides of influence ripple throughout the galaxy, which cause new stars to come into existence. So these spirals here are spiral arms. Now, a spiral arm in a galaxy is not a physical arm. It's not something solid that you can actually go out and touch. It's actually a ripple. It's actually a shimmering. It's in physics, it's called a density wave. It's a place where the gas is being compressed in some way. But you could say it's ripples of creative potential, right? So the galaxy ripples here, and stars are born. They come into being, by the millions. A ripple here, a whole new cascade of stars is born right here. So a galaxy is a swirl of creativity, more than a swirl of gas, dust, and the components. And if you come back here to the image, this is that James Webb Deep Field image, where every dot is a galaxy here. Well, I said before that most of this image is made up of galaxies. That's not actually true. Most of the image is made up of dark matter. But actually, that's not actually true either. Most of the image is made up of space, right? And it turns out that space itself is not actually empty, right? In our culture, we often talk about space as being empty space, but space is essentially pure creative potential. So if you look at this image and see, it's like, oh, this image isn't filled with space, it's filled with creative potential. right? Waiting for the right conditions for something new to burst forth. And someone mentioned this previously, that quantum physics has discovered that space itself is full of fertility. It's full of potentiality, right? There's a slide I got from the internet that shows that, you know, each of us and everything around us is almost entirely empty space, right? We're really a pattern of energy fields, a constellation of creative shimmerings rather than something solid, right? You know that, you know, the model of the atom, which has a nucleus at the center surrounded by an electron shell, it's mostly space, right? Imagine a stadium as the outskirts of the atom, and then the nucleus is roughly a baseball or softball at the center of the stadium, and the rest is, well, not empty space, but creative potential. If you take a magnifying glass, and of course we don't have magnifying glasses like this, but if you could, and look at space at a very, very, very tiny level, you would see that space itself is not empty, but it's full of particles coming into existence and disappearing. These are called virtual particles at the level of what's called quantum foam, where quantum mechanics governs the dynamics of things. And particles are evoked into existence out of pure potentiality. They live for a brief moment, then they disappear back into that fertile creative void from which they come. So this is the via creativa, right, embodied as the nature of the cosmos that surrounds us, that penetrates us, that permeates us. The space itself is filled with creative potential. And quantum field theory reflects this. The modern complete theory from quantum physics is what's called quantum field theory, and it says that space is filled with quantum fields, and what we call particles are essentially fluctuations in that field. And so the field itself is where the creativity comes from. And so space, the point here is that space is essentially a creative medium through which creative potentiality expresses itself. In fact, I found this very interesting, right? 95% of the mass of the protons are the particles at the center of the nucleus of all of our atoms, is made from these particles coming out of this quantum foam, this quantum vacuum, which is evoking new particles into existence and then disappearing them. Someone mentioned Shiva and Shakti before, right? This is an ancient idea where things are being created and destroyed in the very instant. But that process of creative formation, that creative coming forth, that generative power, it's what's creating most of the mass of the atoms in our bodies and in all around us. So it's space that's giving the particles in our bodies the mass, not the particles themselves, or at least not most of them. And this generative power that comes from space is the generative power that created the cosmos, right? So the birthplace of the cosmos is right where we are. The generative power that gave birth to the cosmos is right where we are. So it's this via creativa, the unknown, unknowable potential that is ready to flare forth at every moment, that is present all around us. And that's what makes up most of these images. But when you look at all these images, we'll go back here a few slides, remember that most of the image here, most of the universe is space, but it's not empty space. It's creative potential space. We don't really have a good word for it in the West, but other cultures acknowledge space as one of the building blocks of reality, like the four elements: earth, air, and fire, water. Some cultures include space as one of the fundamental building blocks because they see it as having a creative aspect to it. So this creative potential, and I'll just move on to spring, right, is part of a transformative process, right? The via transformativa, where something new is springing forth, something is being generated from this pure generativity, this pure creativity. And so we see this around us in terms of the novelty of the cosmos, right? Things are giving birth. There are new dynamics coming forth. The universe is shining with radiance. I mean, stars are examples of radiant beings that number the night sky in the hundreds of billions. And it's celebrating being by this radiant expressiveness. And I'll show some examples from the James Webb that you may have seen in the news recently. Here's one that just came out last week. This is a star forming region. And what we're seeing here at the very center here is a protostar, which has never been seen before with telescopes. And a protostar is a star which is in the process of forming. So you could say it's like an embryo. Right? It's not quite born yet to be a full star, but it's a star in the process of formation. And the star itself, there's a disk of material here, imagine like a ring, and inside the very center of this disk is the star that's in the process of forming. And what's happening here is this creative ring of material around itself. So stars, like babies and other beings, need a cocoon to kind of generate warmth so they get enough heat to ignite as stars. And so there's a cocoon of gas around it, which forms this disk. And then as the material heats up in here, it begins to throw off matter. And so these ripples are ripples of material coming off the star as it's forming, shimmering out into the nebula that the star is a part of. And so the light from this protostar is illuminating these gas tendrils from the nebula on both ends. And there's also rings of material being thrown off the protostar through gaps in the rings around which the protostar is forming. So only visible infrared wavelengths. Nothing has been seen like this at this scale until the James Webb came along. So it's a really exciting image to see, not just a star in the process of being born, but just to see the surroundings around which these stars are born. Really amazing. It's like studying a baby inside its mother's womb before the baby's even born. So just remarkable, and to see the process of development. Here's another famous example that was one of the first images that James Webb released. This is the Carina Nebula in the southern hemisphere. And this is the place where new stars are being born. Nebulae are clouds of gas and dust, which have the raw materials for making stars. And one of the interests of the James Webb is to study stars inside the nebulae. And so it has this special property of infrared light of being able to see inside. And so you can see these stars glimmering from within the nebula. If this were taken with a Hubble, this would be totally opaque. You wouldn't be able to see it through it, but because it's James Webb at infrared wavelengths, you can see the stars inside of it. And we can also see that these brand new stars up here are just being born right now. And as they're being born, they're basically evaporating the nebula around them. And so scientists want to study, how does this transformational process happen, whereby a nebula is transformed into stars, and then the stars in the nebula have an ongoing relationship. So it's like how the gas and dust around the nebula is sculpted by the stars. And it shows that star birth, right, is a creative activity that shapes both that which is birthed and the birther together. Right? So mothers and children shape each other through this process of development. And so the nebula, the mother, gives birth to the stars, and then the stars shape the mother in all kinds of interesting ways. Right? Mothers, you know what I'm talking about, right? How have been shaped by your children by the process of giving birth. And so these new stars have actually sculpted these cliffs with the radiation that they give off and how they're evaporating away the nebula around, which was the egg which gave birth to them. Really remarkable, these cliffs. And we're seeing what's happening inside the nebula and outside as the nebula changes over time. So it's a transformative process. And then this is a wider view of the same area taken with the Hubble. And it shows that this star birth is not always a calm process. The area I'm showing in this image here, I think, is roughly around here. This is a wide field view taken with the Hubble, and it shows there's all kinds of dynamics. There's huge winds happening. There's stellar birth taking place. The winds from these young stars are blowing the nebula around, tearing this nebula apart. You know how babies can have tantrums, they can throw things around. That's what's happening here, is all these cosmic tantrums are spreading things around, but it's also initiating new birth processes throughout the nebula. This is about 50 light years across in this image. So it's a tremendous image. But look at the beauty of what's happening here in these birthing processes. So this birthing is not always a gentle process. It shapes the nebula in very dramatic and unexpected ways. Here's another image of a massive star forming region called Perdia Doradus. And what's happened here is that this nebula has essentially been hollowed out by the formation of new stars. So you have a nebula, the nebula collapses into these thousands and millions of stars, and what's left behind is a cluster of newborn stars. So the nebula goes away, and the new stars are the result of this transformative process. So by this incredible process, nebulae are transformed into stars. Remarkable. Right? One celestial wonder gets turned into many celestial wonders. So life itself is always transforming itself into new capacities, new dimensions of aliveness and wonder. Take a look at this latest image of the Tarantula Nebula. Beautiful, right? So this transformative process that the universe really is the archetype of the template for is dramatic, it's beautiful, it's awe-inspiring. But one thing I take from these images is that the universe is aiming in the direction of beauty. Right? That's part of the function of the universe, is aiming towards greater and greater complexity, interrelatedness, and beauty. I mean, look at the beauty in these images, and look at what things are transforming from beautiful and to a new kind of beauty. So we have, I think, a direction of beauty in the cosmos, where the universe is aiming at beauty because what it's producing moment by moment everywhere is just so beautiful. And I'm not just saying as an astronomer, but just the aesthetics of this is dramatic. And this transformative process of star formation and star birth transforms not only the nebulae, but the galaxies that these nebulae are a part of. Here's an image. This is the image of Hubble, of a galaxy called NGC 7496. It's just a catalog number. And so this is with visible light, this is what we see. With the James Webb, these red spiderweb lines are places where star formation is taking place. So it's almost like this galaxy is electrified with new life. And you can see how this new life radiates through the entire galaxy, transforming it from the inside out. Right? So the galaxy has a new life process it's in the process of transforming as it gives birth to new stars through all parts of itself. So it's an entire transformative process that galaxies go through their evolutionary lives. And these lives intermingle with each other. Stars begin as nebulae. They form stars like the sun, which live their lives. They develop into different kinds of stars, leave this world through planetary nebulae, which goes off to create new nebulae, which creates new stars, which can create larger stars, the supernovae, black holes, neutron stars. But it's a creative process that both gives birth to new possibilities, as well as enriching itself through the process. So over time, these nebulae become more complex. They can create more possibilities of objects, such as stars that can form planets, planets which can sustain chemistry, which can sustain life. And so over time, this transformative process complexifies and generates new novel forms through this process. This is another one of the first images from the James Webb. This is Stephan's quintet. So it's a quintet of galaxies, galaxies that are interacting with each other. Remember, each of these galaxies is a collection of 100 billion stars, gas and dust. And what's happening is that these stars or these galaxies are interacting with each other. And through their interaction, they're sparking new possibilities. These reddish areas here are places where new stars are being born. So imagine these galaxies off by themselves, all kind of alone, doing their own thing. Then when they come together, their interaction sparks something new. So for me, it shows the power of the transformative power of relationality. When you're able to be impacted in a relationship, something new can be born, right? As is showing this cosmic template, where new forms of stars are being born through this interaction with other galaxies. So the galaxies themselves are not only being transformed, but they're being transformed in relationship. And so it shows that the cosmos has developed this template of relationality as a transformative path. Once again, the via transformativa coming to us through the cosmos. And then one more, and then we'll pause for some more reflections. This is another spectacular image from the James Webb called the Cartwheel Galaxy. This is a galaxy that somehow had an encounter with another galaxy, which is not shown in this image, but that galaxy came close enough to it to brush by it, and it disturbed it to such an extent that it's shimmering with new formations of stars. Now, how did it make this swirl in the center? Nobody knows. How did it make this ring of shimmering new stars? Nobody knows. But we know that somehow this galaxy was impacted and is coming alive in a new way through its relationship with this galaxy, which is not in this image, but was clearly a big impact on it. Let me just stop the share right there. Let's see. So maybe we can reflect together. All right. How are we being shaped by the Via Transformativa right now? Or any reflections people have? Oh, I see there's some artwork coming up here.
Yes. Can you?
I see it. I see it's like two lobes.
It's supposed to be. This is not. I'm not an artist. Let me put that as best as I can.
Yeah, I can see it now. Do you want to describe what you're showing?
Well, this is my own primitive art, but it's coming out backwards on the camera. It's supposed to be a multidimensional therapist took me through meditation, and this is I'm a very good artist, not like my wife, but it's yin on the side, and it's a zero point between the infinity symbol, and it's mainly different spectrum of light that came to me in drawing. And this is my thought.
Yeah. Well, I see a relationship of opposites there with yin and yang and different polarities, and there's a symmetry there as well. Your internet connection isn't very good, so we've lost you there, but thank you for sharing that. Any other reflections on the Via Transformativa or anything else we've been seeing? You can raise your hand on Zoom. I can see you, or Kathy. I see you there. Go ahead, Kathy.
Well, I just want to thank you for one thing. This is fascinating, and I have no real astronomy background at all. So I have just been blown away by the fact that somehow we are seeing billions of years ago, and I still can't grasp that.
Isn't that amazing? That we live in like a time machine, that the further away you look, the farther back in time you're seeing. It's like the entire history of the universe is just laid out in front of us.
Yeah.
And that's what James Webb is designed to study, is that entire history of the universe, all the way back to the very beginning. And you may have read in the paper a few days ago, it discovered some of the very first stars and galaxies that the Hubble had no chance of seeing, but it's already seeing those very first stars and galaxies, which were very different than the ones today. So it shows that the universe has gone through a transformative process, as we all do, right? It's growing and aging and developing, as all parts of it are.
Right. Well,
Yeah.
thank you very much. It's
Oh.
just fascinating.
Yeah, thank you, Kathy.
I have another quick question.
Yeah, please.
Okay, it's regarding the expansion of the universe.
Yeah.
I'm wondering, given the rate, and it's increasing, is that correct?
Yeah.
Is there an estimate at the point at which communication would be impossible between any two bodies that could possibly support life? And in general, what thoughts and ideas do you have about that?
It's probably too big a question to get into in too much detail here, but yes, physicists have predicted there will be a time when things will be so far apart, we won't see any other galaxies, right? They'll be too far away from us and kind of over our cosmic horizon. So we live in a sweet spot for astronomy at this time in cosmic history, where we're at a time when we can see the wonders we can see. While we can see them, we can see these faraway galaxies. At some point, space will expand so much, these galaxies will be so far apart that we won't see them anymore and they won't see each other anymore. It'll be a very different universe. So, which is really remarkable. So we're in a time when this kind of astronomy is possible, and it won't always be possible. But this is, of course, billions and billions and billions of years in the future. It's not going to happen overnight. But it shows that we're in a remarkable time. We're in a time when stars are being born at really incredible rates. Galaxies are developing, where things are still close enough to actually be influenced and to be known by each other. But that won't always be the case, right? The universe is going to transform and change over time as well. But I also want to point out that I don't think the universe development is a linear process. So we can't say, well, it was like this in the past, it'll be like this in the future, because I give room for nonlinear creative potentiality to evoke itself. So the future could be very different than what we predict. So I'm just kind of putting that caveat out there. But yeah, there is the prediction that space will continue to expand and the universe will continue to become bigger and bigger and change what we see overall. Yeah. Thank you. Let me take Maureen's question and we'll look at some more slides. Hi, Maureen, welcome.
Hey, thank you. I'm a member of Jubilee, and we are going through the vias at rocket speed in our internal growth as a community. And I'd like to know if you could be available to have discussions, as you're talking about the different vias and the metaphors and the realities that are paralleled in the universe. I think this would be so helpful for us to see our process, and invite you and ask you to join us in some of these discussions.
Sure, I'd be happy to. Yeah, just I'll share my contact information with you, and or Michelle has it. We can be in touch. Yeah.
Okay, great.
Yeah. You're welcome. I think it's an important point to recognize that these cataclysms, these transformative processes, these collapses, these breakdowns that we find in our culture and in our lives right now have kind of larger dynamic. There's a creative process here that spans the cosmos, right? Stars explode. They have terrible days too, right? But in that explosion, the raw materials for something new is being born. Nothing is ever wasted in these processes in the cosmos, right? That which is destroyed is the raw materials for the birth of something new, right? So destruction gives rise to creation, which gives rise to destruction, which of course is an ancient idea. But just to see that these dynamics, are happening all over the place, that there's a kind of a cosmic framework, I think can be very helpful, right? Because I can see that there's something larger holding us and holding this process throughout all of this, right? And if the universe is really made out of transformative creativity, we shouldn't expect things to be the same moment by moment by moment. But if we can embrace that and ride with it and find the inspiration from the larger perspective of the cosmos, I think it'd be very helpful. Yeah, so we can reflect on that together. Yeah.
Great, thank you.
Let's take your question again. I didn't get your name, 981006. Go ahead and mute, and then briefly, we're going to finish up.
Yeah, I wanted to bring this into the DNA molecule, the double helix, because you showed how everything was coming together at some stars and there was a birth taking place. The DNA molecule is double helix in pairs, very much like the infinity symbol, very much like some of the artists draw.
And it's a spiral.
The moment of vulnerability, when it's creating, is when the DNA molecule untwists. At that moment, a new cell is born of the 60 trillion cells or so that make up our body. So in that process, could we ask for like a protective divine light that stops mutations that cause cancers, et cetera, as our cells are replicating in our bodies?
Yeah, it's a great question. Yeah. Once again, there's a spiral pattern too. A helix is a spiral pattern, right? Extended spiral galaxies, spiral patterns, right? I think of the phantom galaxies, spirals of creativity. the knowledge shell, the logarithmic spiral. Exactly, right? You see it replicated all over. We live in a pattern cosmos. And if we can identify some of these patterns in our lives and see them reflected in the cosmos, we can see that this patterning is present everywhere. Right? And we're part of that patterning. So thank you for sharing that. Yeah. Let me finish up with a few slides to talk about the Via Positiva. Go here. Right. Oops, here we go. The Via Positiva, right? This is the growth, the expansion, the path of beauty and awe, right? Summertime, right? When things are at its highest, that radiant beauty, the fascination, the wonder of the world around us, the path of awe and beauty. And so, if you see this, and this is an image of what's called a quasar. This is one of the objects that the James Webb has been designed to study, and quasars are essentially the superactive cores of massive galaxies. And so what's happening, this is an artist's conception, we don't have pictures of something like this yet, is you have a supermassive galaxy at the core, I mean a supermassive black hole at the center of this galaxy. All right, this supermassive black hole is basically has matter spiraling into it, creating this tremendous jet. And yet this supermassive black hole, this via negativa, is causing a via creativa process. So some destructive object, which we would call destructive, is actually a linchpin, which is creating a new pattern of creativity around this galaxy. And it's leading to these jets bursting out of the galaxy. It's leading to new patterns of organization. And it's part of the via transformativa. So we have all the vias represented in this image here, right? We have the via positiva, which is the awe and wonder of it, the via negativa, which is the absence at the center, the supermassive black hole, which is organizing new patterns of creativity, creativa, and a transformativa process, right? So in this galaxy, all these vias are coming together in cosmic processes. Artist conception, by the way, we won't have images of these, but James Webb will study galaxies like this at different stages, at different distances from Earth. Let me give you another example closer to home, which also came across the news wires from the James Webb. This is the pillars of creation at a slightly different wavelength. Almost looks ghostly, but I see this as almost like a reaching. I mean, I can almost feel the reaching in this image, where there's something in the cosmos where it's reaching for something, it's extending itself, it's yearning for something through this process. And you know what's happening here is that these new stars that are being born in the nebula are beginning to push out of the nebula. They're creating their own pathways. They're yearning forward to leave the nest, to go out and to do something new. But in that process, the entire nebula is expressing some kind of yearning. I almost see a horse head up here, or some living image here. So I see that there's a yearning, there's a positivity, there's an optimizing that's happening in the cosmos that's being expressed in these pillars of creation. And even the astronomers label this the pillars of creation, right? There's some magnificent, awe-inspiring process at work here. Tens of thousands of stars being born here. Now, some of these stars that are being born are also forming planets around them. And so James Webb is going to study planets around other stars. In fact, it has. This is an image that came back just a few weeks ago. And this is the first directly imaged planet outside our solar system ever taken. So since James Webb, we had pictures of this. So this is the star in the upper part of the image where the cursor is. And what James Webb was able to do was to actually image the planet right next to the star. So the star is represented by this the star symbol right here. This is not a star. This is actually the planet itself, imaged directly with James Webb. We've never been able to take images like this before. To actually have a picture of a planet around another star, that's been impossible until the James Webb, with its resolution, with its capacity for seeing at infrared wavelengths, which planets glow at, and it's studying this planet at different wavelengths, different forms of infrared light. First time we've ever seen a planet around another star. Now, the big question that everyone wants to know is, stars form planets, do planets always form life? Is there life around other stars? Well, James Webb is helping to answer that question as well. This is a supersized planet, about twice the size of Jupiter, around another star. And it's given the technical name WASP 96b, which is a terrible name, of course. But it's an exoplanet. It's a planet outside of our solar system. And the James Webb was able to study the atmosphere of this planet and detect that there's actually water there. So this planet is over 1,000 light years away, and James Webb was able to detect water. Well, everywhere on Earth where we found water, we found life. So is there life here? We don't know. We don't see the signs of that, but we see the building blocks of life as we know it in the form of water. And so James Webb is finding these elements that are critical for life around other stars, in other planets, in other solar systems. So life is part of this via positiva direction, right? Life is positive, it's optimistic, it's reaching forward, it's yearning for something new, right? Life itself is actually a kind of a yearning of the cosmos to reach for something unseen before. And I want to finish with this one image I like a lot of a galaxy called Centaurus A. And if you take a look at it, there's a lot going on here. Essentially, this is a galaxy that's been warped by another galaxy. Let's take a look at the visible light image up here. See how there's a little kind of a warp in this ring going through it. So some other galaxy came by and warped that galaxy somehow. So once again, you've got the influence of relationality, where it caused a shimmer to go through this galaxy. This galaxy is about 13 million light years away. There's a supermassive black hole at the center, and that supermassive black hole is devouring lots and lots of material right now. So much so that the galaxy is actually burping huge bubbles of gas and material from the center of it. Not from the black hole itself, but from that area around the black hole called the accretion disk. So there's material coming out, which you can see at radio wavelengths. You can see this disk of material, which is dust in the galaxy, very visible at infrared light. And you can see this very intense beam of radiation coming from the area around the black hole at X-ray light. So it's a composite image, which has been put together with 4 different telescopes to get a more complete picture of the galaxy itself. Now, you may have just studied the galaxy at visible wavelengths and say, well, this is the galaxy. It's like, well, no, but look at it in X-rays. This is the galaxy. It's like, no, look at infrared. Is this the galaxy? Is this? They're all the galaxy, but all together, it forms a more complete picture. And I kind of use this as a metaphor for the vias, right? So all of the vias are different pathways to the mysteries and dynamics of the cosmos. But we need all of them because together they form a whole complete picture of how the cosmos, how life lives and transforms. So this galaxy is speaking to us from different wavelengths. If we can develop the ears and the eyes to see, we can see it. And the cosmos, in the same way, is speaking to us from different wavelengths through the different vias. Each of the vias has a different pathway into this mystery, and we need all 4. And so that's our goal, as Thomas Berry said, is to become the cosmos in human form and to enact these vias in our lives, in our experience, in our communities, for the benefit of the whole, to become part of the beauty making of the cosmos, to weave a more beautiful world through our actions and in alignment with the vias, so that we can bring the dynamics of the cosmos to our lives, to our communities, for the benefit of the whole. So I'm just gonna stop sharing right there, pause, and thank everyone. We've got time for questions, we've got time for reflections, but thank you for allowing me to share this. I mean, I'm an astronomer, so I get excited about this stuff anyway, but it's always fun to have someone to get excited with about these objects. We got a question from Pat and John. Hey. Oh, you got muted. You have to unmute.
Hi. So 35 years ago, we left Washington, D.C. for Matthew Fox's program, ICCS, and it was the year that Brian Swim's class was became Canticles of the Cosmos. I think
Oh.
it was 35. Wow.
What a treat. Yeah.
Yeah, so now our lives have been transformed by dementia, and we're open about it. He has it, I'm exploring it like crazy. And we're involved heavily with groups that are meeting dementia with creativity, mourning what is, celebrating what is, play, all of the things. And I'm beginning to see that so much that is happening there is, what if dementia is another language, another way of seeing?
Mm.
And I'm wondering if you know anyone who's exploring this. I know I'm working again with the VIAs. And if I were to describe Dementia Action Alliance, which has really been transformative for us, it is via creativity and transformativa, big time.
Yeah.
And it totally transforms the way the relationship is.
Yeah.
So do you have any thoughts on that, or organizations living through the VIAs?
I don't, but perhaps someone else who's in the community tonight might. It sounds like,
Oh, I see a hand raising.
yeah, you want to unmute yourself and share?
Yes, and my website, drdarylpoke.com, under influences is Dr. Elmer Green, who's passed, whose wife had Alzheimer's. His view is incredibly expansive on the Alzheimer's experience. So if you want to view it, the video's there. It's also on YouTube, but you can go to my website and not have to scan through all the stuff on YouTube.
Would you
But
put that in the
it's
chat so
Dr.
she
Elmer
can
Green, biophysicist, who
Yeah.
is my mentor, and he's deceased, and his wife is now deceased.
Can you give me the website? Your website? I don't know you. We're now
Sure.
living in Virginia, so.
Oh, sure, that's okay.
You can
Dr.
put it-
Daryl Poke, that's
Or type-
DARYLPOKEA.com. And look under influences, and you'll get that video under influences of Dr. Elmer Green.
Yeah.
And his wife.
Alice Green, yeah.
Yeah.
Right. Elise, actually.
Okay, it's you're Daryl Pokey, Pokea. That's right.
Yeah, you could
It's
put it in the
pronounced
chat. as well.
Poke. It's pronounced Poke, but we can do that another time.
Yeah.
Okay, okay.
Thank you. Well, I'm glad we're making these connections. And that's a whole different way of viewing dementia than I'd considered. So thank you for sharing that.
Our marriage is better every year. That's common.
Oh, I was just going to say, ask you to put that in the chat box because it wasn't clear.
Yeah, put your website in the chat or any
Put
other
the
resources.
website
people
in
want
the
to-
chat box.
Question
Great.
here.
Go ahead, Doug, is that right? Yeah.
Yeah.
Go ahead.
Thank you so much. Maybe asking a question that takes an even larger perspective, and that's the multiverse concept. Brian Greene at Princeton said, probable in his opinion, but not provable. What's your take on multiverses?
I would go along with that, probable but not provable. And that, who's to say that the universe that we know is the only one out there? If we live in a creative cosmos, that perhaps there's other universes being born at every instant. And other people have also said that perhaps our universe gives birth to other daughter universes through black holes. And maybe they give birth to other, and maybe it's more like a network of universes. I don't know.
Others might have different natural laws going on.
Absolutely.
Who knows?
Right. Never underestimate a creative cosmos in terms of the diversity of what it can produce.
Yeah.
So, yeah,
Thank you.
yeah. Any other reflections as we kind of come to a close? Gary, go ahead. Welcome. And then I see a few other hands. Oh, Gary, we can't hear you.
Oh,
No.
you. There.
Gary.
How about now?
Good. Yeah.
Yeah, I had to turn off my Bluetooth.
Oh, okay, there you go.
Thank you so much for this. It was awe-inspiring and just the realization that everything is so interconnected and that we're all one and we're all part of this. I just have the way I understand it, before the Big Bang, there was what's called a singularity. Is that correct?
Well, we don't know what happened before the Big Bang, but yeah, there was some kind of single event or singularity from which we think things came from.
And
But go ahead.
and what I have read is that even time was encapsulated. There was no time until the Big Bang.
That's
that
that's the current theory. Yeah, time and space were both born out of the Big Bang.
Now, as the universe expands, what happens with time? Does time change?
It depends. Time, you know, what Einstein showed is that time depends on the conditions, right? Time is changed by gravity, and then time is changed by relative velocity at the same time. And so when you say time, you mean whose time? Time on Earth, time on Alpha Centauri, time can be very different in different places of the universe. So there's no single clock for the whole universe, which is what Einstein showed. Now, the other thing about time is that some people said, well, maybe time isn't really a good yardstick for the universe. Maybe we should be saying creative process, right? So maybe, right, really the timeline for the universe is really creative process rather than seconds, minutes, hours, years, something like that. That seems to be more accurate.
Well, that makes
ahead.
more sense because we're the ones who use time.
Yeah,
The universe has no time.
exactly. And if it's a unity, right? There's no part. So what's keeping the time? It's one single developing unfoldment. Yeah.
Cool.
Yeah, it's mind blowing. Yeah.
Thank you.
Go ahead again. We'll take one final question or comment, and we'll close. Yep.
Okay. Most of the mystics had a dark night of the soul experience.
Yeah.
Could that be a metaphor parallel to the black hole, taking something dark and turning it into something positive? Because they all said going through the dark night of the soul experience brought them closer to the divine.
It's a great question. I mean, many of them talked about
And
how,
also, we go to Yeshua, Jesus in agony in the garden, his muscles all abandon him. He's totally alone. So what does he do? He turns in the Aramaic, he doesn't call it the Father. He says in the Aramaic, the translation is radiant one. He turns his mind and heart to the radiant one. And there's light. And the light gets him through the dark night of the soul when he's about to die.
amazing. I mean, I see so many cosmic images and what you're sharing here and what the mystics have reflected upon. It's like there's an inner universe of the mystics that's reflected in the outer cosmos. Really beautiful to share this. Yeah. Wow. Well, I think we're out of time now. So, Michelle, any closing comments or announcements for Jubilee?
No, I'd just like to thank everybody for coming tonight and for donating to Jubilee. We really appreciate the donations. And Stephen, thank you. This has been amazing and educational and enlightening and just really cool. So we have recorded it and links will be available. And if you need a link to it, because you want to watch it again, just send me an email. My email address was in the emails that I sent to all of you. It's just michelle@jubileecommunity.org. Thank you.
All right.
Wow.
Thank you, everyone. I wish you a wonder-filled, awe-filled time until we see each other again. Thank you and take good care. Have a good night, everyone.
Thank you.